This is a demonstration called the Rubberband heat engine. We have a wheel, and what you do is you cut a small section out of the middle of the spokes, and with the remaining two parts at the hub and the rim, you bend the ends over so that you've got hooks on them, and then you put a rubber band in to span the distance between those two hooks. So if you have a look here, we've got spoke with a hook, rubber band, spoke with a hook, spoke, rubber band, spoke, spoke, rubber band, spoke, and this runs all the way around the wheel so that all the spokes are being replaced with rubber bands. You then have to rebalance the wheel so that you can get the center of mass to sit back near the axle again. Otherwise what it will want to do is always drop to a point where the center of mass of the wheel is at the lowest point. We've got this one as balanced as we possibly can. It's rather difficult to get it perfect. You then have a pair of high power floodlights over here. We've got red filters on them to try and turn as much of the light into heat as possible. And what you would think is going to happen over here is that these floodlights will heat up the rubber bands. The rubber bands, when they get hot, should expand. And if rubber bands expand over here, there's a little less tension in them than there is over on rubber bands on this side. So what will happen is that overall the rubber bands will pull the mass of the wheel in that direction. The center of mass will move away from the hub over to there, and it will want to drop down to the bottom. Okay, so the wheel should rotate a little bit, brings a new set of rubber bands into the lights, they heat up, so they should expand, the wheel should pull over that way, and this rotation should keep going round and round in circles while the light's on. So let's turn the lights on, we'll see if it starts up and watch it for a little bit, and then we'll come back and have another look at what's going on. So if you've been watching carefully, you'll notice that when I turned the light on, the wheels started rotating. That's fine, but it's actually rotating in the wrong direction. So the original explanation was that when we turn the light on, the rubber bands expand over here. That puts more tension on this side, shifts the center of mass to that side of the axle, and then the wheel should fall down. Okay, and so this thing should rotate in a clockwise direction. And you'll notice it's actually going anti-clockwise, and there's a really simple explanation for that. It is that most materials expand when you heat them, but rubber bands, they actually contract. They do exactly the opposite. And so when the rubber bands over here get hot, they contract, and so they pull, the higher tension over here pulls that edge of the wheel in this way, shifts the center of mass in this direction, which then rotates down, and so this process keeps going, and you end up with an anti-clockwise rotation of the wheel. Okay? And just to convince you that there's not some magical trick going on here, I can now turn off the light, and you'll see that the wheel will stop rotating fairly quickly. You may get a little bit of back rotation on the wheel if it's slightly out of balance as the center of mass comes back to the bottom, but you'll notice that basically that anti-clockwise rotation that we had has stopped entirely. Okay? And so you normally think about this thing as a heat engine in the sense that you put some amount of heat in, and what it will do is it will turn some of that heat into work and some of that heat into waste heat. Okay? And as an engine, this thing's really inefficient. You put a very large amount of energy in, something on the order of 200 watts or so, and you get a very small amount of work out of it. Okay? If the wheel's really well balanced, it doesn't take too much energy to make it rotate round. But if you knock it out of balance and you've got some center of mass that's sitting away here that you have to lift, then the wheel just won't turn at all. And so that gives you some indication of how little work you get out. And then the rest of that energy goes out as waste heat, and the efficiency of this thing is really low. Another way you can demonstrate how little work you get out of it is to hang a mass off the side, but it's a little bit of a trickier thing to do. The easiest way to do it is just to knock the wheel out of balance and have the centre of mass sit at the bottom. Anyway, if you want to try this one at home, aside from balancing the wheel, the other key to it is choice of rubber bands. If you choose thin and rinky rubber bands, it might work, but they'll start to snap after a while. Or if you're unlucky, it just won't work at all. What you want is these nice fat rubber bands that you can get. If you're in Australia, the purple ones that Australia Post use for the mail are really good for doing this, but if you go out and buy them, you want really nice fat juicy ones. So there it is, the rubber band heat engine.